Now we are going to study question from April 2014 exam. Question 3. Everyone give the heading. April 2014 exam. Question 3. I am going to read this question for you guys. Try to see the scenario here, what this question want to say. A piston of a reciprocating engine has a mass 800 kg. How much mass? 800 kg. Engine has a stroke. How much is the stroke of engine, everyone? Stroke of engine is what? Stroke of engine is what? 2.4 meter. And bore and mass is how much? Okay, before that I will write down first of all mass. Okay, how much is the mass, everyone? Mass of the engine is what? Sorry, mass of the piston is what? 800 kg. Then stroke is how much? How much they have given us a stroke? Stroke is what? 2.4 meter. So whenever we have a stroke, from stroke what we can find out, everyone? Amplitude of SHM. And what will be the amplitude of SHM, everyone? Amplitude of SHM. What is the meaning of amplitude of SHM? Amplitude of SHM means what? R. Okay, stroke by 2. Half stroke. Very good. Stroke by 2. So that will be what? 1.2 meter. Everyone try to see the scenario here. So in this way what we got? Amplitude of SHM. Then they have given us a bore. Okay. The dia of bore. And how much dia of bore? Bore means what? We will denote it by small d. And small d will be equal to what? 950 mm. That 950 mm is what? 0.95 meter. At an engine speed 90 revolution per minute. Okay. So here n is what? What will be the value of n? 90 revolution per minute. Try to see the scenario here. So therefore corresponding omega will be equal to what? What will be the corresponding omega? 2 pi n by 60. So 2 pi n means what? 90 divided by 60. So everyone please do the calculation and tell me the value of omega. Everyone please do the calculation and tell me the value of omega. So 2 pi into 90 divided by what? 60. How much value of omega? 9.4248 unit radian per second. So in this way what we got, guys? We got omega. Everyone try to see the scenario here. So we got omega. The piston rod dia. Okay, dia of rod is how much? We will see where to we need this dia. Dia of rod is how much? 340 mm. See, here we have a two dia, guys. One dia is of dia of bore. Dia of bore is what? 950 mm. And dia of rod is what? 340 mm is what? 0.34 meter. The piston may be, see, how to identify any question is belong to the simple harmonic motion. Always there is a what? There is a word, there will be a motion. Means here, see, you can see any question from this chapter, any question. You will get all the questions, there is a word simple harmonic motion. And here the piston may be assumed to move in simple harmonic motion. Means here motion of the piston is simple harmonic motion. Try to see the scenario here. So here motion of the piston is what? Simple harmonic motion. Now what they are asking us in the A part? Velocity of the piston when 0.8 meter from the TDC. Try to see the scenario here. In A part what they are asking us? In A part what is our target? What we have to find out? Velocity of the piston when it is from what? How much distance from TDC, everyone? It is from, try to see this drawing. This drawing is very very important to us. That our line diagram. Guys, this line diagram is very very important to us. So this topmost point will be what? What will be topmost point? TDC. Bottommost point is what? BDC. Exactly in between what? Mid stroke. Fixed point. Mid stroke or what? What we will say? Mid stroke or what? Fixed point. Everyone getting my point? Try to understand the scenario here. So always whenever we have a such type of questions, always try to draw the drawing. Then this will be what? This distance. Distance between TDC and BDC will be what? Stroke. And then everyone, this distance will be what? What will be this distance? R. This will also this distance. This is what R. R means what? Amplitude of SHM. And what is the value of R? We calculated 1.2 meter stroke by 2. And then what they are asking us? Velocity of piston 0.8 meter. Guys, exactly wording is what? Velocity of piston when 0.8 meter from TDC. So here suppose where is our point P? Where is the location of point P, guys? This is the location of suppose point P. So this is at this location. At how much distance from TDC, everyone? How much distance from TDC? It is distance from a TDC, everyone. Try to see the scenario. But while what is the relation for velocity? What is the relation for velocity, everyone? What is the relation for velocity? Velocity is equal to what? Omega into under root of R square minus X square. Check it, guys. Is it okay? Something, is it correct or wrong? Check it your notes, everyone. Okay, now what will be the value of X here? What will be the value of X here, guys? If we need a velocity, we need a X. What will be the value of X here? What is the meaning? R minus 0.8. So guys, X means what? Distance from a fixed point or distance from a midpoint or mid stroke. So this distance will be X. So X will be become what? R minus 0.8. Everyone try to see the scenario here. Very simple discussion. So X, R is what? 1.2 meter minus 0.8 meter. So it will become what? 0.4 meter. So velocity will become what? How much omega we calculated? 9.4248. Check it, everyone. Under root of R square means what? 1.2 square minus 0.4 square. So what will be the value of velocity at 0.8 meter from fixed point? 9.4248 into under root of 1.2 square minus 0.4 square. How much value we are getting, everyone? 10.663 unit meter per second. See, guys, very simple discussion. Only 5 minutes we required to solve this one. I told you, this chapter is very, very important from exam point of view and very simple also, okay? So first of all, write down all these given things and then draw this diagram, write down target of A part. In A part, show the point P. That is what our target point. At that point, we have to find out velocity. Try to draw this drawing. After drawing, write down these things. Everyone, please complete this discussion. Now, what is our target in B part, guys? In B part, what they are asking us? Maximum acceleration of the piston. In B part, what is our target? In B part, we have to find out maximum acceleration. It means A max. And what is the relation for A max we studied? A max will be equal to what? Maximum acceleration is equal to what? Omega square into radius. So A max will be equal to what? Everyone try to see the scenario. What is the value of omega square? 9.4248 square. 9.4248 square. R is what? 1.2 meter. So please everyone do the calculation and tell me the value of A max. Everyone please do the calculation and tell me the value of A max. 9.4248 square into 1.2. How much value everyone getting? 106.5922 unit meter per second square. Okay. In this way we got value of maximum acceleration. Anyone have any doubt in this discussion, guys? Try to see the scenario here. So please everyone complete this B part. Everyone complete this B part. Now what they are asking us in the C part, guys? Nature and magnitude of the stress in the piston rod just after TDC. Guys, this question is a little bit, we need some knowledge of strength of material also, especially simple stresses and strain. But don't worry, guys. Stress means what? Force by area. So here what they are asking us in C part, stress in piston rod means for getting a stress, here they are asking us nature and magnitude. Guys, there are two types of nature. One is a compressive nature. If force is compressive type, then compressive nature. If force is tensile type, means the length of rod is increasing. if the force is outward, guys, suppose, see, I am going to explain you what is the meaning of nature. First of all, before going further, see, suppose this is what a rod. On that rod, suppose I am applying this force. Guys, try to see the scenario. Suppose this is force F, I am applying on both sides. So due to this F, what will happen, guys? What will happen to the length of the rod? Length of rod will increase. So it means what, guys? Here the force is F is what? Tensile in nature, tensile force. So here stress due to F will be what? Tensile stress. Now another force is what? In simple stresses and strain, we will study these things. Now another type of force is what, guys? This is what happened due to this force? What happened due to this force F? Compression occurs. Compression means what? Okay, decrease in length. Compression means what? Decrease in length. So stress due to this F will be what? Stress due to this F will be what, guys? What will be the stress due to F? Compressive in nature. So here nature is what? Tensile, and here it is what? Compressive. Okay, everyone, write down these things in your front page of your notebook. Everyone, please write down these things in front page of your notebook. Front page or last page, guys. Everyone, please write down these three things. These two things. This is a generalized things. And also write down sigma is equal to F by A. Force, or we don't write, just write down. This is tensile, this is compressive. Just write down these things. So due to tensile force, what will happen? Increase in length. Due to compressive force, what will happen? Decrease in length. Means here tensile stress in nature, compressive stress in nature. Now try to see the scenario here. So what they are asking us here? Now what they are asking us here, guys? What they are asking us? Sigma rod, stress in rod, and we have to find out its magnitude and nature. Magnitude means what is its value, and how to get that stress, guys? Sigma rod is equal to what? Force in rod divided by area. Okay, so this is what our target. A means what? Which area we have to consider? Area of rod. So for getting stress in rod, first of all we have to find out force in rod. What we have to find out, guys? Force in rod. Now again I am going to read this part here carefully, because there are few things I have to mention here. What we have to find out? Nature and magnitude. So stress has two types. Stress has two types of nature. Okay, first type of nature is what? Compressive. If the force is compressive. Another type of nature is what? Tensile. And we have to find out nature and magnitude of the stress in the what? In the piston rod just after TDC, guys. What is the meaning of just after TDC? Means what? Our piston is at what position here? What will be the position of piston, everyone? What will be the position of piston here? What will be the position of piston? Approximately at TDC. So what will be the position of piston here? Approximately at TDC. Try to see the scenario here. I am going to draw the drawing of piston here. Just drawing of piston. This is what a piston here. Guys, there is one thing I have not written. Okay, what is the given from the given things? From the first paragraph of the question, I have not written here on these given things. Guys, which thing is missing? Which thing is missing, everyone? This is what a piston, everyone. Huh? This is what is missing from there, guys? Pressure. I have not written pressure. What is the value of pressure, guys? Everyone, what is the value of pressure? Okay, so everyone, please in given thing, please write down 110 bar. Okay, what they have said? Pressure at the piston means just after TDC means what? At TDC, what is the pressure at piston? Okay, pressure at piston is what? 110 bar. 110 bar means what? 110 into 10 raised to the power 5 Newton per meter square, guys. Again, at the front page of your copy, your notebook, 1 bar is equal to 10 raised to the power 5 Newton per meter square, or Newton per meter square means what, guys? Pascal, PA. Please write down front page of your notebook. 1 bar means what? 10 raised to the power 5 Newton per meter square, guys. Never forget these things. Huh? This is very, very important. 1 bar means 10 raised to the power 5 Newton per meter square. We need these things in heat also. Okay, everyone getting my point? Try to understand the scenario here. So here they have given us a pressure, and they have given us what is the position of piston here? Just after TDC. Just after TDC means approximately at TDC. So when piston is at TDC, guys, here piston is at TDC. Suppose piston is at TDC, what will be the acceleration of piston, guys? When piston is at TDC, what will be the acceleration of piston? Maximum. When piston is at TDC, what will be the acceleration? Acceleration is maximum. A is equal to what? Here A is equal to what, everyone? A is equal to what? A max. Okay. Acceleration is what? A max. Anyone have any doubt in this discussion? Now here I am going to represent forces on the piston. So first of all, what is the mass of piston here? What is the mass of piston? 800 kilogram. What is the mass of piston here? 800 kilogram. Now what will be the weight due to that mass? Weight means what? Gravitational force. So what will be the value of gravitational force on the piston? So value of gravitational force means what? Weight. So what will be the weight, everyone? Weight will be equal to what? mg means 800 g. G stand for what? G means what? Not a gram here. G means acceleration due to gravity. Now there is a pressure also. What will be there, guys? Here pressure is also there. What will be the value of pressure? 110 bar means 110 into 10 raised to the power 5 Newton per meter square. Everyone try to see the scenario. And pressure, how pressure acts, guys? Throughout that piston. Throughout that piston means on that piston pressure will act. So here how to show pressure? So here see this small line. So this small line will represent what? Pressure. And due to that pressure there will be pressure force. Guys see, in our theory I have given you one note. Pressure force. Pressure force means what? Pressure into area. So here pressure is acting on what? Piston. So which area we have to consider? Piston area. Which area, guys, we have to consider? Suppose this is water piston here. Huh? This is water piston, our piston. So on that piston there is a uniform pressure will act. So pressure is what? So due to that pressure force will create. And how to find out pressure force? Pressure force is equal to what? Pressure into area. Are you getting my point? Try to see the scenario here. Now, so here weight, this is a pressure acting. Due to that pressure force will create. Now, suppose here there is a rod. Suppose rod is applying some force on the piston. And guys, I try to see the scenario here. A rod is applying. What is happening, guys? Rod is applying some force on the piston. This is what, guys? F rod. What is the meaning of rod? Means what? Force on the piston due to rod. This F rod means what? Guys, what is the meaning of this F rod? F rod means what? Force on the rod. What is the meaning of F rod, everyone? Force on the rod, force on the piston due to rod. Now guys, everyone, see, actually there is some rod. Okay, actually there is some rod here. Actually there is some rod. This rod is pushing that piston, and just imagine that. What is happening? We don't know exact scenario what is happening. Just we assume that suppose this rod is what? Pushing that piston. When rod is pushing that piston, so I am going to separate that rod imaginarily. So what will happen, guys? What will happen? When this rod is going to push the piston, means going to do like that. So this rod will apply this force on the piston. So this is F rod. So this is, what is the meaning of this F rod, everyone? What is the meaning of this F rod? What is the meaning of this force? What is the meaning of this force? Force on what, everyone? Force on piston due to what? Due to rod. Okay, means rod is applying force on piston due to rod. Okay, now see, I told you for every action there is an equal and opposite reaction. Suppose I am going to push the board. Suppose I am going to do push-ups on this board. Whenever I am going to do push-ups on this, if I am going to push this board, what will happen, guys? When I am going to push this board, what will happen? I am applying some force on the board. So what will happen? Opposite force applied by the board on me. Guys, what will happen? When I am going to apply some force on the board, opposite for every action, Newton's third law, guys. For every action, there will be equal and opposite reaction. So when the rod is applying force on the piston, then opposite force will be applied by the rod on the piston, guys. So here, try to see the scenario here. So this will be what? F rod. So this F rod will be what? Here I am imaginarily separating, guys. Actually this rod is in contact with piston. Actually suppose this is water piston. Everyone try to see the scenario here. Suppose This is what a piston, guys. Huh? This is what a piston. This is what a rod. Actually, this piston and rod actually connected to each other. But imaginarily, I want to show these forces. See, if you remember our wedges numerical, actually block and wedges are contact with each other. But for making the thing simple to do the calculation, we have imaginarily separated. The same thing is happened here. Means here imaginarily this is what a rod. So here, if the rod is applying some force on the piston like this, guys, if this rod is applying the force on the piston like this, then what will happen, guys? Opposite force piston will apply on this rod. Guys, what will happen? Suppose rod is apply this force on this piston. What will happen? According to Newton's third law, piston will apply opposite force on the rod. So what will be this one, guys? What will be the meaning of this F rod? Force on what is it mean, guys? What is it mean? What this F rod means, everyone? What is the meaning of this F rod? What is the meaning of this F rod, guys? What is the meaning of this F rod? Force on rod. What, everyone? Force on rod. Force on rod due to what, everyone? Due to piston. Okay. And if we need the value of sigma rod, we have to find out stress in rod. So if we need the value of stress in rod, what we have to do? If we need the value of stress in rod, what we have to do, guys? What we have to do, everyone? We have to find out this F rod. And for getting this F rod, we need this F rod, guys. Huh? Try to see the scenario here. This F rod means force on piston due to rod. This F rod means what? Force on rod due to piston. Means both are, suppose one is action, another is reaction. Guys, are you getting my point? Try to see the scenario. So our target is what? We have to find out stress in rod. For getting stress in rod, we have to find out this F rod. For getting this F rod, we need this F rod. Okay, means first of all, for getting stress in rod, we have to find out force on rod. And for force in rod, we have to find out force on piston due to rod. Everyone getting my point? So first of all, what is our target? We have to find out this F rod. From this F rod, from this force on piston due to rod, we will get this value of rod. Everyone getting my point? Try to understand the scenario here. Huh? Anyone have any doubt in this discussion? Good. Now the next point is what? Guys, in our basic definition of simple harmonic motion, I have given you a first starting point. Simple harmonic motion. Guys, go to your theory, everyone. Just read the first definition, guys. The first definition of simple harmonic motion. Everyone, please go to your theory. And what is the definition I have given to you, guys? Please go through your theory. And what is the definition I have given to you? Fixed point. Okay, guys. Okay, good. What is the definition I have given you? CSHM is a special type of periodic motion. It satisfies the following two conditions. What is the first condition? Acceleration always directed towards the fixed point. Now, guys, what is the position of piston here? Actually, piston is at what location here? Actually, piston is at what location? Guys, try to understand the point here. This point is very, very important. What is the position of piston? Actually, piston is at this location, at this TDC. When piston is at TDC, where is the fixed point, guys? Where is the fixed point? Below the TDC or above the TDC? Where is fixed point? When piston is at this location TDC, guys. This is a just point diagram. Here I am showing you detailed views of piston. When piston is at this location, at this TDC, where will be the fixed point? Above the TDC or below the TDC for this location? Below the location, below the TDC. So now what will be the direction, guys? See, I'm showing two arrows here. Now tell me, a direction of acceleration downward or direction of acceleration upward. Out of this, which condition is true? When piston is at TDC. And guys, remember one point, acceleration always directed towards fixed point. So which arrows indicate directed towards fixed point? This downward arrow or upward arrow? Which arrow indicate, guys? Downward means which arrow indicate towards fixed point? This arrow or this arrow? When piston is at TDC. This arrow, guys, downward arrow means downward arrow towards fixed point. Everyone try to see the scenario here, towards fixed point. Guys, are you getting my point? Now suppose, just imagine that piston is at, so out of this one, This one is correct, this one is wrong. Okay, for when piston is at TDC. Suppose piston is at BDC, what will be the direction of acceleration, everyone? Just imagine that. In that scenario, it is not there. What will be the direction of acceleration? Upward or downward, everyone? Out of these two, which one will be the correct? Upward or downward when piston is at BDC? Upward, because directed towards fixed point and fixed point is upward. So here this one is correct one, this one is correct one, and this is what? A wrong one. Okay guys, are you getting my point? Try to understand the scenario here. So here, according to this point, what will be the direction of acceleration here when piston is at BDC? Sorry, when piston is at TDC, direction of acceleration is what, guys? What will be the direction of acceleration, everyone? Towards fixed point, and here with respect to piston, fixed point is what? Below. With respect to TDC, piston is below, mid stroke is below, fixed point is below. So our acceleration is what? Downward. So here, downward. Guys, are you getting my point? Anyone have any doubt in this discussion? Try to understand this scenario. Anyone have any doubt in this discussion, guys? Getting this point is very, very important. Now, why direction of acceleration is important here? Why I am mentioning direction of acceleration? Then again, in theory, I have given you one note, guys. Just go through your theory. Initial note, guys. Means after I have given you one note. I think note number 4 means first note maximum velocity, second note maximum acceleration, third note xa is equal to xb, fourth note I think I have given you. What note I have given you, guys? Forces in the direction of acceleration considered as positive, opposite forces we have to consider negative. Here we will not consider motion, guys. Here we don't have to consider about motion. What we have to consider here? Forget for the sign convention for the forces. Forces in the direction of acceleration considered as positive and opposite forces as a negative. So here, what are the forces in the direction of acceleration here, guys? Which forces here is in the direction of acceleration? Which forces here is in the direction of acceleration, everyone? Okay, 800G weight and pressure force. And what about this F rod, guys? What about this F rod? See, while studying piston, we don't have to consider this force, guys. We have to consider, see, while studying piston, everyone try to see the scenario. While studying piston, we have to consider only this much, this point, guys. This one. We don't have to consider this F rod. This F rod, guys. This F rod is acting on the rod. Here we are studying forces on the piston, guys. We are talking about piston. Means from studying piston, we will get this F rod, and whatever the value of F rod, this will be the same F rod. Okay, everyone getting my point? Try to see the scenario here. Very, very simple discussion. So guys, so I have given you the forces in the direction. I have given you note number 4. The forces in the direction of acceleration considered as positive and opposite forces negative. Don't worry about motion in simple harmonic motion, guys. Whenever we are studying simple harmonic motion and how to identify question belongs to simple harmonic motion, there will be one note is there. There is what? One note is there. What is the meaning of that note? Means, see, not note, in the question they clearly mention simple harmonic motion word, guys. From that point you will come to know that, oh, simple harmonic motion. In simple harmonic motion, don't worry about motion. You have to worry about acceleration, and acceleration always directed towards a fixed point. Suppose, guys, our piston is at this location. Suppose our piston is at this location. What will be the direction of acceleration here? Suppose piston is at this location. What will be the direction of acceleration, everyone? Upward, guys, because fixed point is what? Suppose piston is at this location, everyone. Suppose piston is at this location. What will be the value of acceleration? What will be the direction of acceleration? Upward or downward? Downward. See, at this location, everyone, it is above the fixed point or below the. So acceleration is what? Downward. So guys, and why acceleration direction is important to us? Because our most favorite things, entire mechanics is depends on that law. Which is that law, guys? Our entire mechanics is depend on which law, guys? I told you, everything in mechanics is depends only on Newton's 3 law, and out of that most important law is Newton's second law of motion. Guys, most important thing, most infinite time most important thing in mechanics is what? Newton's second law of motion. Means everything is Newton's second law of motions. Everything means all these three laws, first law, second law, third law, but out of that most difficult to understand and most important also, that is Newton's second law of motion. So what is by Newton's second law of motion, guys? What is Newton's second law of motion, everyone? What is Newton's second law of motion? By Newton's second law of motion, what, everyone? Applying Newton's second law of motion to piston. Second law of what? Applying Newton's second law of motion to what? Where we are going to apply? To what? Applying Newton's second law of motion to what? Piston. So what is Newton's second law of motion is saying, guys? What is Newton's second law of motion is saying? What is Newton's second law of motion is saying? Summation of forces is equal to what? Mass into acceleration. Okay, try to see the scenario. So here which direction? See, if you remember discussion from linear motion, we are talking about motion, direction of motion, forces in the direction of motion considered as positive and opposite forces negative. But in this chapter we will not follow that analogy. In this chapter we will not follow that analogy of linear motions, means forces in the direction of motion considered as positive and opposite forces negative. In this chapter, whenever there is a chapter of simple harmonic motion, forces in the direction of acceleration considered as positive and opposite forces negative, guys. Remember the point. And the next point is what, guys? What is the next point, important point here? What is the next important point here? And acceleration always directed towards fixed point. Suppose if the piston is above the mid stroke, acceleration is downward. If piston is below the mid stroke, acceleration is upward. Just remember this point. Okay. Now any doubt in this discussion, guys? Now here, what are the forces in the direction of acceleration in this scenario? What are the forces here in the direction of acceleration? First of all, this 800G. First of all is what, guys? This 800G. So 800G is positive. Now here we are talking about forces. Pressure is not a force, but due to pressure there will be pressure force. Due to pressure there will be what? Pressure force. This pressure is acting on what? Piston. So what we have to consider? So pressure force will be what? Pressure into what? Piston area, or, and here, guys, for us clearance is what? Negligible. So whatever the area of piston, same will be the area of bore. Guys, whatever the area of piston, suppose piston is circular, so whatever the area of piston, same will be the area of bore. So because here we are assuming negligible clearance, guys, actually there will be some clearance there, but here what is our assumption here? Means for the throughout mechanics, our assumption is what? Whatever the area of piston, same will be the area of bore. Okay, so here pressure into what? What will be the value of pressure force, guys? Pressure force means what? Pressure into what? Pressure into which area? Which area we have to consider? Area of piston or area of bore? Okay. And what will be the another force? What will be the another force here? Another force here. F rod. Okay, because here we are talking about the piston. Here, guys, our discussion is about what? Piston. Try to see the scenario, guys. Because this discussion is little bit long, so you have to understand each and every point. So, and here F rod, we have to consider this F rod because we are talking about forces on piston. So this F rod is in what? Opposite to the acceleration, means what? Minus F rod is equal to what? How much value of mass? Mass is what? 800 kg. Mass is what? 800 kilogram. 800 g is a weight, that is not a mass. So 800. Acceleration is what here? What is the value of acceleration? Mx. Guys, are you getting my point? So F rod will be equal to what? What is the value of F rod, everyone? 800 g plus pressure into area of bore. Check it out, guys. Minus 800 into Amax. Anyone have any doubt in this discussion, guys? And why we are calculating F rod, guys? From F rod we will get a stress in the rod. Okay, so F rod will be equal to what? 800 multiplied by 9.81 plus pressure value is how much? 110 into 10 raised to the power 5. What will be the area of bore, guys? Bore will be circular. So area of bore will be equal to what? Pi by 4 and into dia of bore square. And how much dia of bore here given? 0.95. So area of bore is what everyone? 0. Pi by 4 into 0.95 square. Check it out. Check it guys in your theory. In your numerical, sorry, not in theory. In your numerical, check it guys, dia of bore is how much? 0.95. Okay, so minus 800 into A max. A max we calculated in B part. 106, I have written for my reference. 106 point, how much? 0.5922. Check it guys, huh? Anyone have any doubt in this discussion? Check it. Check it everyone. So please everyone do the calculation. So 800 multiplied by 9.81 plus 110 into 10 raised to the power 5 into what? 0.25 pi into what? 0.95 square minus what everyone? Minus 800 into 106.5922. 106.5922. How much everyone we are getting a fraud? 800 multiplied by 9.81, 110 into 10 raised by 4, 0.95 square minus 800. Okay, how much value getting everyone? 614.507 unit Newton, 5071 Newton. Okay, so we got what we got everyone? We got the value of F rod. Anyone have any doubt in this F rod? So from this F rod, try to see the scenario here. From this F rod, what we are going to do? From this F rod, what we are going to do guys? We are going to calculate sigma rod. And what will be the sigma rod everyone? What is the relation for sigma rod? Sigma rod is equal to F rod by area of rod. So stress in rod will be equal to what everyone? Stress in rod will be equal to what? Force in rod divided by what everyone? Area of rod. So sigma rod will be equal to what? Sigma rod. So sigma rod will be equal to F rod 7719. Check it guys, huh? 7719614.5071 divided by what will be the rod guys? Rod is again circular. So what is the dia of rod here given? 340 mm. Dia of rod here. How much dia of rod? 340 mm. So pi by 4 into 0.34 square. So please everyone do the calculation and try to find out stress in rod. So here we need, this question is combination of simple harmonic motion and simple stresses and strain guys, huh? We are going to study that chapter. So 7719614.5071 divided by what? Pi by 4. Pi by 4 into 0.34 square. Okay everyone, what is the value we are getting everyone? Press the ENG. There is one symbol in your calculator guys. There is one symbol in your calculator, ENG, engineering calculation. 85 point. Okay, everyone press the ENG. After pressing equal to, everyone press the ENG. 85.00252 into 10 raised to the power 6 C. Unit of force is what? Newton. Unit of area is what? Meter square. So here unit will be what? Newton per meter square. And 10 raised to the power 6 means what guys? 10 raised to the power 3 means kilo. 10 raised to the power 6 means what? Mega. So stress in rod will become, in strength of material, in simple stresses and strain we will study in detailed way. So 85.0252 mega Newton per meter square. Okay, everyone getting my point? Try to understand the scenario here. Anyone have any doubt in this discussion guys? 85.0252 mega. 10 raised to the power 6 means what? Mega. What is the meaning of 10 raised to the power 6 everyone? Mega. So here we got stress in rod. Stress in rod. This is what a magnitude guys. This is what a magnitude. So this is what a value of magnitude everyone. Magnitude of stress in rod. What will be its nature everyone? Can you tell me nature? Guys see. Which type of force acting on the rod? Which type of force? See, on rod this force is acting. So what will be the nature of this force, guys? What this force is doing? This force, the force which is acting on the rod due to piston, what that force is doing? It is doing compression or tension, guys. The force which is compression. So what will be the nature, everyone? So in bracket we will write down the nature. So nature is what? Compressive in nature. Okay, everyone getting my point? Try to see the scenario here. Anyone have any doubt in this discussion, guys? Anyone have any doubt in this C part? Okay, guys, because A and B part is very easy here. Free marks there. But interesting is what? C part, and here we used our concepts of, some concepts of Newton's second law of motion, this force diagram. Okay, some concepts of linear motion, except direction, how to take the sign convention for the forces. Instead of motion, here we consider direction of acceleration. And remember, acceleration is always directed towards a fixed point, guys. Here acceleration is what? Acceleration is always directed towards a fixed point, guys. Remember this scenario here. Anyone have any doubt in this discussion, guys? Okay, good. So now, guys, first of all, what you have to do? Try to draw the drawing. I told you, most important thing in mechanics is drawing. If you want to pass, suppose you are at the boundary, means most of the times I observed my lot of students failed at grade 7. And most important reason is what? Drawing. So if you want to go from grade 7 to grade 6, I don't want you should pass at grade 6. You should pass with good grade. So guys, the most important thing in mechanics is what? You are drawing. So try to draw the bigger drawing, this drawing. First of all, draw this drawing. After that, this one, and then this one, guys. Okay. First of all, this one, then this one, and then this one. Please complete this point, everyone.